You know the scene, right? In Star Trek, a starship kind of stretches and then whoosh, it just vanishes into a streak of light. It's the iconic warp drive. But is it just a cool special effect, or is there some actual, honest-to-goodness physics behind it? Well, today, that's exactly what we're going to dig into, the incredible science behind what might be humanity's ultimate dream.
And this quote right here, it just hits the nail on the head. It perfectly sums up the puzzle we're trying to piece together today. On one hand, you have this incredible dream of exploring the galaxy. But on the other, you have the fundamental laws of the universe saying, nope, not so fast. So, is there a way around it?
All right, so first things first, let's talk about the dream. Why on earth do we even need a crazy idea like a warp drive? Well, the answer is simple, but it's also absolutely staggering. The sheer, unbelievable scale of space. I mean, for decades, Star Trek has painted this amazing picture for us, right? A future where humanity is out there, exploring strange new worlds, seeking out new life. It's this powerful, inspiring vision that's gotten generations of scientists and dreamers, myself included, looking up at the stars and wondering, what if?
But then, reality hits, and it hits hard. 4.24 light years. That's the distance to our nearest star, Proxima Centauri. Now, that number might not sound all that big, but trust me, the distance it represents just completely dwarfs any journey we have ever taken.
Let's try to wrap our heads around that. Using the fastest rockets we have today, getting to our closest neighbor would take almost 80,000 years. That is longer than all of recorded human history. So yeah, it's pretty clear that if we ever want to actually go to the stars, building slightly faster rockets just isn't going to cut it. We need to completely rewrite the rulebook on travel.
But you know what? Back in 1994, a physicist named Miguel Alcubierre offered this incredible glimmer of hope. He came up with a theoretical solution that, really for the first time, took the whole idea of warp drive out of the realm of sci-fi and dropped it right into the world of theoretical physics. And this is it, the Alcubierre Drive. And it's a truly wild idea. It's not about moving through space faster than light. Instead, the idea is to move space itself. It's a super clever workaround for that universal speed limit.
So, how in the world would that even work? Okay, picture yourself on a surfboard, but for the universe. The drive would basically scrunch up space-time in front of the ship, pulling your destination closer, and at the same time it would stretch out space-time behind the ship, pushing you along. You're not really moving, you're just riding a wave in the fabric of space-time.
Now this is the really genius part. The whole trick revolves around something called a warp bubble. Inside this little pocket of space-time, the starship itself isn't moving at all. It's just sitting there. Since it's the space around the ship that's doing all of the moving, you cleverly sidestep Einstein's rule about nothing moving faster than light. No laws of physics broken. Pretty neat, huh?
It all sounds absolutely brilliant, doesn't it? A perfect solution. But, and you knew there was a but, here comes the big cosmic catch. To actually bend space-time like this, you need a very, very special and deeply problematic ingredient.
That ingredient has a cool name, exotic matter. And no, that doesn't just mean it's hard to find. We're talking about a theoretical type of stuff with properties that seem to fly in the face of everything we know, specifically something called negative energy density. Let me break down just how bizarre this is. All the normal matter we know, from you and me to the biggest stars, has positive energy. It creates gravity that pulls things in. But to make a warp bubble, you need the exact opposite. You need matter that has negative energy, something that would create anti-gravity and push space-time outward. That's how you expand the space behind you. And the thing is, we have never, ever seen anything that does that.
And that, right there, is the heart of the problem. This stuff would basically violate some fundamental rules about how energy is supposed to work in our universe. And, to make matters worse, we've never found a single trace of it anywhere. This isn't just a small engineering problem, it's the massive roadblock standing in our way.
But hey, let's just imagine for a second. Let's say we stumble upon a secret stash of exotic matter somewhere. Problem solved, right? We can build our starship? Well, not so fast. We'd immediately run into another problem of, well, astronomical proportions. The energy bill. Seriously, the amount of power we're talking about here is it's hard to even describe. The very first calculations for this drive suggested you'd need more energy than exists in the entire known universe. Now, thankfully, newer models have brought that number way down, but you'd still need the energy equivalent of multiple planets just to power a single jump. The power requirements are almost as theoretical as the exotic matter itself.
Oh, and as if that wasn't enough, you've got a few other minor details to sort out. Like, how to stop the crew from being literally ripped to shreds by the gravitational forces. Or how to shield them from the deadly radiation the bubble itself would create. And then there's the small problem of not accidentally vaporizing your destination with a massive blast of energy when you arrive. The little thing.
So, after going through all of these massive, almost impossible challenges, it's time to ask the big question. Where does this leave our Star Trek dream? Are we ever going to boldly go where no one has gone before?
I think the verdict is pretty clear. When you need matter that might not exist, energy reserves the size of a planet, and you have to solve a dozen other life-or-death engineering puzzles, a working warp drive is, for now at least, staying firmly on the pages of science fiction.
But that absolutely does not mean we've given up on reaching the stars. Instead of trying to bend space-time, real-world scientists are focused on ideas that are a bit more down to Earth, even if they're a lot slower. We're talking about things like powerful fusion rockets, enormous solar sails that are pushed by the light of stars, or even giant, multi-generational ships that would carry humanity across the void over centuries.
And that really brings us to our final thought. The gap between the fiction we love and the scientific facts we know seems huge right now. But then again, think about it. History is just full of ideas that were once called impossible, that are now just part of our lives. So I'll leave you with this. Is warp drive a forever fantasy? Or is it just a physics problem that we haven't figured out yet?